Hello, I'm Trond.
And I'm John, and we would like to welcome you to this immersive experience inside the human body, showing the journey of drugs from the moment they are swallowed and until they are distributed throughout the body.
Throughout this journey, we will explore drug absorption, which is the process by which drugs enter the body when taken in tablet form. In the throat, the tablet is swallowed and descends into the esophagus. In some cases, larger tablets may get stuck in the esophagus of patients with a narrowed lumen.
However, for the majority of patients, this stage of transportation is uncomplicated, and the tablet swiftly reaches the stomach. In the stomach, also known as the ventricle, the tablet enters the gastric juice. This fluid, produced by the gastric mucosa, is highly acidic and colorless. Some tablets are coated with an enteric coating to resist gastric acid. This coating not only provides protection for the gastric mucosa against irritative drug molecules, but also serves as a barrier.
But look, however, in this case we have a film-coated tablet, and it can be observed that the outer layer dissolves in response to the acid. Subsequently, the tablet progresses into the small intestine through the pylorus. The rate of gastric emptying can vary, which in turn affects the absorption time. Typically, the presence of food tends to slow down the emptying process. The small intestine plays a crucial role in the gastrointestinal system, as it is where the majority of drug molecules are absorbed. Upon reaching the small intestine, the tablet disintegrates and dissolves, releasing the drug molecules, which are then separated and prepared for absorption across the gastric mucosa.
Inside the small intestine, millions of villi, small finger-like projections, extend into the intestinal lumen. These villi greatly increase the internal surface area of the intestinal walls, providing a larger surface area for absorption.
And the absorption of most drug molecules occurs through passive diffusion along a concentration gradient, facilitated by the mucous membrane. However, a minority of drug molecules primarily rely on passive or active transport through specific transport molecules present in the intestinal cell membrane.
The extent of absorption is influenced by various characteristics of the drug molecules. For example, molecular weight plays a role, as small and lipid-soluble molecules are absorbed more rapidly. On the other hand, proteins are too large to cross membranes and thus must be administered through injection rather than orally.
The transit time in the intestines can also affect the absorption rate. In patients with diarrhea, the transit time is shortened, potentially leading to reduced absorption.